Okay, Kelly, I'm calling you out on YouTube. Kelly, make sure that you go back and watch the video, part 1. Take notes from part 1 so that you can have all this. Because trust me when I tell you, you will need the notes. So, just a refresher from yesterday.
I do understand.
Shh, stop talking. Okay. Exponent. Stop laughing, Natalia. There is nothing funny about math. And people drinking from other people's drinks.
I'm sorry.
Kelly, you didn't drink from other people's drinks, did you? YouTube wants to know.
No, don't put that in the video. No. You're not recording. Are you please don't?
I hope Kelly's dad doesn't.
See, we are recording. We're so.
I hope Kelly's dad is not watching this video.
No. You're causing me trouble. You're
Okay.
causing me trouble, and I'm gonna get in trouble from this.
Okay.
No.
You're so for doing it.
Okay.
No.
All right. Exponents. Exponents are the little numbers right here. This is called the base. You will need to remember that for today. Okay. This is how we do exponents. If there's no exponent, we assume there's a 1. In fact, my students will, when we start doing stuff like this and dealing with exponents, they will literally go and put 1s by everything.
Looks like inches.
Okay. 0 exponents. If there's a 0, it becomes 1. 45, and it's not degree. I had a 6th grader on a quiz tell me, was it in this class? Well, no, was it?
Like it, though.
It looks like a degree, and they put a totally wrong answer. We haven't been learning about degrees. Why would I put that on your quiz? Okay, so if there's a 0 for an exponent, the answer is 1. And we did this little fun thing. Okay,
It was awesome.
if the exponent is 2, we call it squared, like 4 squared. If the exponent is 3, it's 5 cubed. Or you can just say to the power of 3 or power of 2, something like that.
Or to the 3rd power.
Yep. Variable. That's basically your letters. Exponential form, that's when it has an exponent.
Yeah.
Expanded form, that's when you write it out. Okay. Negatives. Okay. I just check this out. So the current Algebra 1 students had this last year. They had, all of them were here last year from the beginning. I literally wrote both of these, but different examples, of course, and asked them, okay, y'all remember the negative stuff. All right, how does it work? Which one is which? They could not remember, even my honor students. So you see that this can be confusing. If you get confused and you need to go back into your notes or in your book, it's fine. Don't think there's something wrong with you because, like I said, even your teacher sometimes gets confused. You don't use it all the time, so it's easy to also forget. If you use something every day, you know what I'm saying, or all the time, every other chapter even, then you're committing it to memory and you'll memorize it and you won't forget it. This stuff, not as frequent. In fact, I think this is the example I gave them. Anyway, negative exponents. Okay, this, I had to reteach them too. Even though they had it last year, they completely forgot. So you see, they're kind of in the same boat as you. The only thing is, this is y'all's first time. It's supposed to be reviewed for them. And even some of my students that had this last year were like, wait, they had, like it was gone out of their brain. Wasn't even a review. It was like I was reteaching it. So if you're struggling with this, you are in good company with the Algebra 1 students. If it's a negative, you put it on the bottom to make it positive. If it's a negative on the bottom, you move it up as a whole number, kind of like moving on top, and it gets positive. This right here, very helpful. This right here.
I need to watch some videos.
Yes, you do.
Thank you. It's kind of confusing.
And I did another one with them with letters, and that seemed to help. But anyway, we'll be doing lots of examples. So yes.
Will there ever be a time when the exponent is a variable? You have to find that.
Yes, but you're not having to do that.
Okay.
So don't worry about it. Okay, so let's get started on new notes. All right. We got quite a bit to do today.
Are we gonna have work or just notes?
Oh, you're supposed to have work, so we've got a lot to do. All right, here we go. If numbers in exponential form have like bases, meaning they have the same base, they may be multiplied and divided. And I'm going to give you the examples of that.
I was drinking coffee for a second.
What?
I thought you were drinking coffee for a second.
No. I'm feeling dehydrated today for some reason.
How many waters did you drink today?
I already had one.
Jesus.
We don't say
Sorry.
I'm gonna have to be fighting Coach Cole for the bathroom between classes. Okay. 3 stars. When we have same bases, this is the key word, same bases. Add exponents when multiplying. Add exponents when multiplying. I'm going to give you an example. Let's say I have 3 to the power 2 times 3 to the power 3.
I know how to do it.
No, but shh. Calm down, eager beavers. Are the bases the same?
Yes.
Kelly, do you see this?
Yes, I do.
The bases, Joseph, do you see that?
Yes.
The bases, you see, bases are the same, right?
Yes, ma'am.
We're multiplying. If the bases are the same and you're multiplying, we're going to add the exponents. So it looks like this. 2 plus 3 gives me 5. I'm not going to go any further. I mean, we can solve 3 to the power 5. I need you to know this. So once you write that down, sit back and look at it and make sure you understand what I just did. Before we move on, if you have any questions.
It's yours. Sorry. Drink it too fast.
It's because you're sharing drinks with other people.
It's not.
You've forgotten how to drink now.
I knew you were going to say that.
Exactly. I'm going to throw you under the bus all day long. Okay,
Oh my God.
so bases are the same. You're multiplying the bases, so then you add the exponents. Does that make sense? Any questions so far? Straight now? Okay, how about this one? 5 to the power 4 times 5 to the power of 3. The bases are the same. We are multiplying those bases, so therefore, what do we do to tie it to the exponents? You add them, so that'd be 4 plus 3, which gives me 5 to the power of what, Tanner?
7.
There you go. I'm going to add. Oh, so I forgot to underline multiplying. I'm going to do a different example I didn't have here. What if I have, I'm going to push y'all to the limit.
Please don't.
What if I had a to the power of 4 times y to the power of 3 times a to the power of 2? Ooh. Italian. Oh, I like Joseph's got his hand up. Just a second. Joseph.
Maybe we do a to the fourth power plus a to the second power. So
Okay, so what bases are the same here?
a.
Do y'all see that? A's have the same bases, right? And Joseph, what operation are we doing with the A's and the Y's? It's all what? Multiplying, dividing, adding, or subtracting. That's right. When the letters are right next to each other, we're multiplying them.
I know.
So we're multiplying, the bases are the same. So Joseph, what do you do to the exponents?
You add them.
Okay, so then I have a to the 4th plus 2 power times y to the 3rd power. And Joseph, 4 plus 2 is?
6.
So it's a to the 6th power times y to the 3rd power. And that is your answer, because you can't do any more with that. Excellent. Y'all get that?
Yep.
Y'all are like, don't tell Algebra 1 this, but y'all are doing better on the exponent stuff right now than they are. And they've already had this for a year. Yes, ma'am?
I've already had this for 2 years.
Well, 2 years, I didn't teach this to you.
When I was in 6th grade, they did.
I taught you, oh, but that was last year. So it hadn't been 2 years. You had it
Oh.
last year.
Sorry,
There you go.
no last.
Okay, so 1 year, because I had you 2 years ago. I may be, see what happens when you drink other people's drinks? You forget things. You like
totally
lose
forget
your
things.
mind. All right, so we're moving on. You will subtract exponents when, whoops, that says we, when dividing, oops, I'm running out of room.
How big do y'all write?
Subtract exponents when dividing. So we just got through adding exponents when multiplying the base, but if dividing the base, you're going to subtract. For example, 2 to the 5th power divided by 2 to the 3rd power. Fractions, as you recall, that's the same as dividing. The top number divided by the bottom number. Now, Madeline, are the bases the same?
Yes.
That's right. The big number is the base. We are, in fact, dividing. The little arrow there. So then what do I do to the exponents, Madeline?
You can try.
That's right. Guys, this is very important. The top number always goes first. You will always have a subtraction sign no matter what. And then the bottom number goes next. So 5 minus 3 is 2. Good job.
That's not bad.
That'd be like if I had a to the 5th power divided by a to the 2nd power. The bases are the same. We're dividing, so we subtract. So sit back, look at it, tell me if you understand it. Or if you don't understand it, I should say. Any questions so far? All right. What if I have this? 2 to the 3rd power divided by 2 to the 5th power. Tanner, how would I write that?
2 divided by 2 cube
Divided by?
subtracted
Say 3 minus.
3 minus 5.
Very good. Notice up here, top number minus bottom number. Top number minus bottom number. It is okay to have that the bigger number come second. Because what is 3 minus 5, Tanner?
-2.
Yes, ma'am. Oh, no, Kelly. I have a well, no, you weren't here yesterday. Atalia, I have a negative exponent. I can't have a negative exponent. How do I make it positive?
Well, you'd have to put it in like a fraction.
Okay, and
And put, since that would be on the top, you'd have to put it on the bottom.
yeah, man, you're doing great. This is a negative exponent. We cannot have a negative exponent. You have to put it into a fraction. Now, it's a whole number, so that is kind of like a numerator, so you got to make it, put it as a denominator, and it becomes positive. And 2 squared is 4, so your answer would be 1/4. So write that down, sit back, and make sure you understand it.
It's not that bad.
Oh, you're right.
How is it a negative? How is it a 4?
Because 2 squared is 2 times 2, it becomes 4.
Oh, okay, now I understand.
Okay,
Not wallet times.
any questions?
Shatters.
Here we go. If an exponential expression is raised to a power like this, looks like that. That's 2 to the 4th to the 2nd power. You multiply, and I'm going to give you examples, of course, the exponents. Y'all are going to do great. Just make sure you have really good notes, because you may be referring back to these a lot.
If I watch the video, I'll be fine.
Yep.
Yeah, I understand it already.
Shh. Keep writing.
Sorry.
Okay. Let's go back to this that I put in there, this example. 2 to the 4th power to the 2nd power. So I have 2 exponents, one on the inside of the parentheses, one on the outside. You will multiply if this happens, the exponents. So that's really 2 to the 4th times 2 power, which is 2 to the 8th power. Which, if you work it out, is 256. So sit back and take a look at that. See if you have questions. Yes, ma'am.
How is it 256?
Because this is 2 times 2 times 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5, 6, 7, 8. If you do 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. et cetera, et cetera.
64, 128, 256,
There you go.
and then
All right, shh. Okay, we get the idea. Does that help?
Yes, thank
Okay.
you. I didn't understand it before, but now I do.
It's amazing.
All right. Let's do some examples, and then we're going to jump into the book. Now, make sure you write all these examples down, because I've got a ton of them, different scenarios. All right, here we go. This is where it gets fun. Y'all ready? B to the 4th power times b to the 2nd power raised to the 3rd power. Oh my goodness. Natalia, I'll let you be my first victim.
okay.
What do we solve first?
B to the 4th power times 2.
Times 2.
Well, the 4 times 2.
Why are we doing 4 times 2?
Because they have the same base.
The bases are the same. We're multiplying. So what do you do to the exponents?
Multiply them. Or add them, I think.
Bingo! Okay, so she's correct. You're working in the parentheses first. Don't worry about that 3 yet, but you're working here. The bases are the same. We're multiplying, so we add the exponents. If I write it, you write it. So 4 plus 2 is
6
6. So it's b to the 6th power
times.
to the 3rd power. Now what do I do, Talia?
You do b to the 6th power plus 3.
If they're on the inside and outside, what do I do here?
Multiply them.
There you go. Okay, when they're on the inside and outside, we multiply them. So that's b 6 times 3.
Which is b to the 18th power.
B to the 18th power. Very good. Make sure you write all of this down.
b times b times b. That's complicated. It's a
But
lot. It's a lot.
it's attention to detail.
It's a lot.
You gotta go slow, and you have to have attention to detail. Does everyone have it?
Yes, ma'am.
All right, here we go. Here's another one. B to the 4th power divided by b to the 2nd power raised to the 3rd power. Who wants to be my next victim? Tanner?
We do 4 minus 2.
Okay, so we're going to work inside the parentheses. Bases are the same. We're dividing, so we're subtracting exponents. Very good, Tanner. So I have 4 minus 2 raised to the 3rd power. So what do you get? 4 minus 2 is?
2.
Now, Tanner, I have an exponent on the inside and outside. What do I do with them?
You multiply.
That's right. So it's b 2 times 3. And what do you get?
B6.
B to the 6th power. Very good. Good job. Y'all are doing really good. Does everyone have this? Kelly, you got it? All right. Let's do another. How about if I have, oh, this is good. X to the 4th power times y to the 2nd power, all raised to the 3rd power. Someone different. Someone want to guess at how to do this? All right, Talia, you want to guess? Go ahead.
Okay, so you have different bases.
You have different bases. So if you have different bases, can I add the exponents in here? Correct. The bases are different, so we cannot add. the exponents. So then what can I do with this? I have this 3.
Well, you can't do anything really on the inside.
Correct, she's right. You cannot do anything on the inside.
So you would just do x to the 4th power plus y to the 2nd power.
Well, that's a multiplication.
Didn't I say something?
You said plus.
Oh.
That's okay.
X to the 4th power times y to the 2nd power, and then times 3, like
Oh.
exponent 3.
Okay, let me show you. The exponent, remember right here and right here, when they're on the inside and outside, what do we do with them?
Multiply.
We multiply. We have an inside and outside, and over here we have an inside and outside. So we are multiplying that 3 with this 2, but we're also multiplying it with that 4. So that becomes x 4 times 3 times y 2 times 3. Do y'all see that?
Yes, ma'am.
Do y'all see that? Joseph, do you see that? Okay. So, Atalia, what is 4 times 3? So it's x to the 12th power times y to the
6th power.
6th power. And really, in algebra, if they're variables, if they're letters, we could also write it like this, without the dot there, with them right next to each other, because this and this mean the same thing. With the dot or without it, you're still multiplying them. So either one's acceptable. Any questions? All right, here's another. D3, d to the 3rd power times d. Kelly.
Let me just finish right
Okay.
here. Okay, so since it has the same bases, we add the exponents, but since the d does not have an exponent, you add 1.
Oh, very good. And since we're adding them because we're multiplying, right?
Yes.
So same base, we're multiplying, so we're going to add the exponents, and she's correct. There is no exponent here, so we're going to put a little 1 there. Good job. So that would be D3 plus 1. So what's your answer?
Or just put 4. It's 4.
D to the 4th power.
Is it fair to just write d4?
Yes.
Because I did not do that.
All right. Good job. Any questions on that? See, Kelly, you're already catching up to yesterday. How about x to the 2nd power raised to the 3rd power times x to the 4th power? Let's see, Madeline, why don't you do this one?
Well, both the things are the same.
Okay, but let's do this one first.
Okay.
What can we do here?
You take the 2 and the 3 and you multiply them.
That's all right. So we're going to multiply the 2 and the 3, and I'm rewriting my problem. So 2 times 3 is? Okay, so I'm rewriting my problem. X to the 6th power times x to the 4th power. Now, what were you going to say?
Since the things are the same, you add them.
Since the bases are the same and we're multiplying, you add the exponents.
Mm-hmm.
So I have x6 plus 4, and what's your answer?
X to the 10th power.
There you go. Any questions so far? Put your pencils down when you're done.
There's a big glare right there.
I know. You got it? All right. Let's do some more. 7 to the 8th power divided by 7 to the 5th power. Joseph.
subtract 8 to 5,
Why?
because when you're dividing, you subtract the exponent.
When we're dividing and the bases are the same. So it's 8 minus 5, and what do you get?
7 to the 3rd power.
Very good. All right, I'm about to challenge you. X to the 7th power divided by x times x squared. All right, Talia, work this through.
Because first you have to do the bottom.
Okay,
Your denominator.
that's right.
So because they both have like bases, and x, the first x does not have an exponent, you're gonna assume that there's a 1 there.
Very good. So I'll put a little 1 there.
So you would do.
So and we're multiplying.
So you'd have to add the things. So yeah, x to some power, and x to the 3rd power.
That's right. Because we're adding the 1 and the 2.
And so now you're going to do x to the 7th power minus 3.
Why?
Because that's how you do it. I don't know
Because-
exactly why.
Are the bases the same? And what operation are we is taking place?
Division.
So when the bases are the same and we're dividing, we subtract
Which is x to the 4th power.
x to the 4th power. Good. Any questions? Let's do another. Tanner. 3 to the 4th power divided by 3 to the 4th power.
3 to the 1st power.
What?
3 to the 1st power.
Why?
Just 4 divided by 4.
We're 4 divided by 4. Okay, the bases are the same, and we're, what is this? We're dividing, right? So then what do we do to the exponent? So then it's 4 minus 4. What is 4 minus 4?
0.
So 3 to the 0 power, which is?
3.
Nope.
Oh, 1.
There you go. There you go.
Yeah, you really have to solve that one out.
No, because this divided by this will give you 1. But still, I want to work it out just to make sure. All right, Kelly, what if I have 1 over 2 to the negative 4 power?
Negative 4? Oh, we'll put. So, okay, hold on, let me do this. Since the bases aren't the same,
Well, all this is one thing. Can I have a negative exponent?
no.
How do I make it positive?
Let me just check.
That was yesterday, so I think you missed it.
No, I remember you wrote it in positive.
Natalia can help you.
So because you have a negative exponent, you're going to need to flip them
Okay, so where does this go?
on top.
There we go. You can even put it over 1 if you want. And then 2 to the 4th is 16 over 1, which is 16.
Okay, I understand.
You got it? All right, Kelly, let's do another one. What if I had 3 times 5 times 3 times 5 times 3?
Are those all exponents?
Nope, just whole numbers.
Okay, just whole numbers.
How many 3s do you have?
We have about 3 3s.
So, right, 3 to the 3rd power. Times, how many 5s do you have?
We have about 2 5s.
There's exponential form, then you can solve it. What is 3 to the 3rd power?
3 to the 3rd power is 9.
Nope. What's 3 times 3 times 3? What's 3 times 3
Okay, 3 times 3 is 9.
times 3?
Is 18.
What's 9 times 3?
Oh, let's see. 24. I mean 27.
And then what's 5 squared?
Hold on, I'm just writing it. And then 5. I mean, what?
What is 5 squared?
5 squared is 10.
No, it's 5 times 5. You told me you had this for 2 years in a row. 5 times 5 is,
Yes, but I have to figure
what is 5 times 5?
out. Oh. 25.
Anyone have 27 times 25 down? I'll tell you.
52.
It's 665.
Everyone get that, or anyone else can get that?
I didn't do it. I didn't.
I think that's right.
I'm just asking if anyone else bothered to try it. All right, we'll just have to guess that she's correct.
675 is what
Let's see. We'll do it again.
Yeah, let's do it again, see who's correct.
Oh, I thought I wrote a 2. Yeah, it is 75 because I wrote my 3 looked like a 2.
There you go.
So when I was adding it, it looked like a 2.
All right, let's do another one that we're going to work in our book. -2 to the -4 power. This is a very important one. Tanner, I have a negative exponent and a negative base. Am I allowed to have a negative base? Yes, you are. Am I allowed to have a negative exponent? Correct, you're not. So how do I make this exponent positive, Tanner?
Fraction. You divide.
Or put it on the bottom, right? So then down here, I have, it's still -2, but it's a +4. Please notice this. The -2, the negative base, does not change when you put it on the bottom. Just the exponent. It becomes negative and now positive. Good job. And because this is in parentheses, it's basically you keep it in parentheses. And for the sake of time, I will just tell you it's 1/16. Any questions?
I have a comment type thing.
What?
A lot of times whenever I see like the number inside the parentheses and then the exponent outside, most of the time if you just flip them, you get the same thing. Like 4 to the 2nd power is 16.
Okay.
Because we had something like that the other day and it was the same.
Yeah,
it
you're
worked
right.
the same way. But it doesn't always work.
All right, any questions? All right, open up your books. We're going to do just a couple of examples since we've done so many. We're doing examples on page 27. I mean, really, I'm not going to do very many here.
But wouldn't it be -16? Never mind.
All right, page 27. I need, let's see, Madeline, read the directions. Tanner, next time you're supposed to have your book out. The very first part.
Write in exponential form without fractions.
Okay, so we're going to just write in exponential form. Look at number 2. It says A times A. Madeline, how would you write that in exponential form?
A to power 2.
There you go. Any questions on how to do this? Any questions on how to do that section? All right, let's look at the next section. Number 10. Joseph, read the directions.
Write in expanded form. Simplify possible.
Okay, simplify if possible. That means work it out if need be. So 10 is y to the 5th power. What would expanded form look like? Joseph.
Y times Y times Y times Y times Y.
Very good. We can't simplify, it's done. Any questions? Look at 12. It's 5 to the negative 3. Italia, how would I do that?
Well, you would do 5 or negative 5. Would it be negative 5?
Oh, all we have is a negative exponent. Oh no.
So wouldn't it just be 5 times 5?
Well, wait, we gotta get rid of the negative exponent first.
Okay, so then you'd put it in fraction form. So it'd be 1 over 5 to the negative, or to the 3rd power.
Now write it in expanded form.
5 times 5 times 5.
All still under 1, still in fraction form. There you go. And it says simplify if possible. 5 times 5 is 25. 25 times 5, Italia?
125.
There you go. That's what they want you to do. So this one, we can't do anything else with it because it's all letters. But this one we can continue working. Any questions? Yes.
Oh, it's in the can I go to the restroom?
Nope. Not when we're doing examples. Look at 16. X squared y cubed. Tanner, how would I write that?
X times Y
Whoops. How many x's?
2. So X times X
Times.
times Y times Y times Y.
Very good. And the part B, we did a lot of examples on. It's similar, so I'm going to go ahead and set y'all free. Y'all ready to go? Okay. You're doing page 27, numbers 1 through 29 odd.
What's a standard numeral?
What are you talking about?
Oh, just for 34 through 42.
You don't need to worry about that. So 1 through 29 odd. That's like 14 problems. It's due Thursday. Get to work so you have plenty of time. Your test is scheduled for Wednesday, a week from today. All right, get to work, get to work.